Suppose we want to get the area of this triangle here. One of the corners or vertices is at the origin 0, 0. What we do is use the other two corners in our formula. So we call one of the corners x1, y1. It doesn't matter which one. And we call the other corner x2, y2. We plug everything into this formula here. So we have a half times the magnitude of x1 multiplied by y2. So we multiply 4 by minus 5. Then we have a minus sign. Then we have x2, which is minus 1. I'll put that in brackets. Multiplied by y1, which is 1. When I multiply 4 by minus 5, I get minus 20. Minus 1 times plus 1 is minus 1, but because of this minus sign here, we get plus 1. So we have minus minus 1 is plus 1. This is going to be a half the absolute value of minus 20 plus 1, which is minus 19. These lines mean absolute value or magnitude. So we make whatever's inside them positive. If it's already positive, well, it just stays positive. But if it's negative, we make it positive. So we want half the magnitude of minus 19. The magnitude of minus 19 is plus 19. So that just ensures that our answer comes out to be positive. So we have 19 divided by 2, which is 9.5. Now we say the area is 9.5 square units. What does that mean? Well, a unit in this case is this distance here. So a square unit would look like this. That's a square unit. So the length of this side of this square is 1. And the length of this side here is also 1. 1 times 1 is 1. So the area of this square is 1. So there are 9.5 of these squares inside this triangle. So this area here is 1 square unit. Now to help you remember this formula, the subscripts here have the order 1, 2, 2, 1. So it's 1, 2 written backwards. 1, 2 becomes 2, 1. We have to multiply x1 by y2 and then subtract the x2 times y1. Now suppose we want to get the area of this triangle, whose corners are 2, 3, 5, 4 and 4, 1. Now to use our formula, one of the corners has to be at 0, 0. And then we label the other two corners x1, y1 and x2, y2. So what we need to do is move or translate this triangle such that one of the corners is at the origin, 0, 0. So what I'm going to do is translate the corner 2, 3 to the origin. So now we translate the other corners. So I'm going to start with 5, 4. So I'm going to move 5, 4 in the same direction as this translation and the same distance as 2, 3 is to the origin. So let's work this out geometrically. This translation consists of a vertical distance of 3 and a horizontal distance of 2. So we move 3 units down and 2 units across. So we do the same with the point 5, 4. We move 3 units down. So this is 1, 2, 3 units and 2 units across. 1, 2. So we end up here. This point has coordinates 3, 1. So 5, 4 gets mapped onto the point 3, 1 under this translation. We do the same with the point 4, 1. We want to get the image of 4, 1 under this translation. So this translation is equivalent to moving this point down 3 units. So it's 1, 2, 3 and 2 units to the left. 1, 2. So we end up here. This point here has coordinates 2, minus 2. So our new triangle has coordinates 0, 0, 3, 1 and 2, minus 2. Our formula for the area of a triangle is a half times x1, y2 minus x2, y1. So we ignore the origin and we look at these two corners. We label one of them x1, y1 and the other one x2, y2, the same as what we had earlier. we plug them into this, so we have a half times the magnitude of x1 times y2, 3 times minus 2, then we have a minus sign, then we have x2, which is plus 2, multiplied by y1, which is 1. So we get a half times 3 times minus 2 is minus 6. We have plus 2 by 1 is plus 2, and this minus sign gives minus 2. So we have half the magnitude of minus 8. The magnitude of minus 8 is plus 8, so we have a half of 8, which is 4. So the area is 4 square units. When it comes to doing the translations, we could still work it out if we have no diagram. As long as we have the coordinates of the corners of our triangle, we just translate one of the corners to 0, 0. It doesn't matter. I could have chosen 5, 4. I could have let 5, 4 go to 0, 0, or 4, 1 go to 0, 0. Let's suppose I let 2, 3 go to 0, 0. How would we do this without a diagram? Well, we just look at the x values. Plus 2 to 0. Well, if you want to find out how many steps you need to make to go from plus 2 to 0, we could just take this 0 here and subtract this value, 2. And the answer is minus 2, of course. It's fairly clear, because 2 minus 2 is 0. So we have to subtract 2 from 2 to get 0. As for the y values, we could take this value and subtract this. 0 minus 3 is minus 3. So we don't even have to do this, because we know that to go from 3 to 0, we have to subtract 3. So we apply those differences to the point 0.54. So it's the same difference, 2 here. So it's 5 minus 2 is 3. And we're going to have 4 minus 3 is 1. So that gives us the 0.31, which is here. Similarly here, we're going to have 4 minus 2 is 2. And we're going to have 1 minus 3. 1 minus 3 is minus 2. So we get the 0.2 minus 2 as before.